Hey there, welcome to Pomodoro Joe for Sunday, November 12th, 2023. Today we're looking at LeetCode problem 815, bus routes. This is a hard problem. All right, so we're given an array, routes representing bus routes, where routes index I is a bus route that the ith bus repeats forever. For example, routes index 0 is 157. This means that the 0th bus travels in the sequence 157, 157, 157, so on and so forth forever. You will start at the bus stop source. You're not on any bus initially, so we're just waiting at the stop. And you want to go to the bus stop target. You can travel between bus stops by buses only. Return the least number of buses, or the fewest number of buses that you must take in order to travel from source to target. Return -1 if it's not possible. All right, so to summarize, we are given a list of routes. Now this is a list of bus routes. So each bus will be the index, and the route will be a list of all the stops that the bus will stop at. Now we are at the source stop, not on a bus, and we want to get to the target stop. Now our goal is to figure out if we can get to the target stop and what are the fewest number of buses we need to take. So if we can't get to the target, then we return -1. If we can get to the target, then we return the fewest number of buses that we need to take. Okay, so this is sort of a graph traversal type problem, and I think we can do this one pretty quickly. Actually, no, that's not true. I think this one's going to take a lot of code, so let's just jump into it. All right, we'll put 25 minutes on the Pomodoro timer, and we will get started. So let's see. I think we will be building up our solution layer by layer. So we'll start simply. We'll have a recursive solution. So here's my plan. So it doesn't look like we need to actually identify which stops we transfer at. We just need to identify the number of buses we need to take. So as long as two buses share a stop, that's all we really care about. We don't really care about which stop they share. Just as long as they share a stop, that means we can move from bus A to bus B. Okay, so we'll first identify what are all the buses we can take from our source stop. So which buses actually stop at this source stop? Those are all our starting buses. Then from those buses, we need to identify, well, which other buses can we connect to? So we'll have to have some data structure that lets us essentially access our list of connected buses given our source bus or given a current bus. So then from our starting bus, we'll find all the connected buses, and then from those buses, we'll find all their connected buses, and we'll keep traversing down until we find a bus that has target as one of its stops. Okay, that seems fairly straightforward. So let's do this recursively here. So we'll start with some function that'll be the num buses to destination recurse. All right, and for this, we just need to know what bus we're currently on. So our start bus. Or maybe I'll just call it bus. Here we go. What bus are we on? All right, so now let's check. Does this bus actually go to the target stop? If this bus goes to our target stop, then we're done. So let's see. If the target is in, all right, we just have to look at routes for this bus. That means that this bus will stop at this target stop, and we can return 1. We had one bus to take, this current bus. Oh, that brings up a question. What if we're already at the target stop? So actually that's a shortcut out here. We'll do this. If the source is equal to target, we don't have to take any buses, so we can return 0. Okay. Otherwise, we'll go through our recursive call. If this bus stops at the target stop, then we just have to take this one bus and we can return 1. Now, how do we get to this bus though? This bus that does go to the target stop. So if this bus does not go to the target stop, that means we have to look at all the connecting buses and try each one of those to see if we can get to the target stop. So let's see, for every next bus in, we need some, I'll probably use a dictionary here. So some dictionaries for connected buses. Now we don't actually have this yet, but we'll figure out how to create this. So for every next bus in our connected buses, let's try to take that bus. So one option is to take this bus. So we'll do a recursive call. and we'll pass in this next bus. All right, and let's see, since we took this bus, the option will actually be 1 plus whatever we return from our recursive call. All right, and then we need to check, is this option better than our current result? So result will equal the min of our current result or this option. All right, now I don't actually have this result yet, so that's another thing we'll have to create out here. So result equals infinite. We want to start our result as something really big, so infinite in this case. So if we find a real result, then we're guaranteed to be less than infinite, and we'll set our result to that real result. And then at the end here, we will return our result. All right, so this is fairly straightforward so far. We'll have this recursive function. We'll go through. If our target is in our current bus route, then we return 1. Otherwise, we have to go through all the connected buses to see if there are options if we take that bus to get to our destination. And if there are, then we just hold on to the minimum option. All right, now of course this is not done yet. There's still a lot more to do. So at this point, we still might be returning infinite here. So we probably want to do a check actually out here. So first we'll get the option. If we take this next bus, then we need to check, did we actually get a real option or did this end up as an infinite response? Because our recursive call can return infinite if it doesn't find a real option, we need to check here, did we get a real option or did this return infinite? So let's see, if option is equal to infinite, then we'll just continue. We didn't get a real option. Otherwise, our option at this point is really equal to option plus 1. So we can do option plus equals 1. As you recall, I removed the 1 from here because if this returned infinite and we had infinite plus 1, that's a problem. So let's just get the answer first. Then if it's not infinite, then we'll add the 1 and compare it to our current result. All right, now the pieces we still have left. We actually need to create this connected buses dictionary, and we also need to create all of our starting bus options, and we need to call this for the first time. All right, so let's assume that this function works, that we can go through and identify our shortest route. So now, assuming that our num buses to destination recurse function works, we need to kick this whole thing off by going through all of the possible start buses. So all the buses that have source as one of their stops. And we can call this function on every one of our start buses, keeping track of which bus gives us the best answer. So outside here, we'll have some result. Again, it'll be infinite. And then we need for every bus in start buses. Now this is something we don't have yet, so we'll have to create that. So every bus in our potential start buses list will have options. So one option will be, let's see here, the number of buses to destination recurse on this bus. And again, we'll have to check to see if we have a better result or if this option gives us a new better result. So our result is the min of our current result or this option. All right, and then out here we return our result. Now at this point our result could still be infinite. It's possible we didn't find an actual answer, so we'll return result if result is not infinite. Otherwise, we'll have to return -1. Okay, so we've broken this down into two pieces. We have our recursive function and we have our loop that goes through all of our start buses calling the recursive function. Now the missing pieces here, we still need to create the start buses list and we still need to have this connected buses dictionary. Okay, and one other thing that we didn't do, I'm just realizing, we didn't check for backtracking. We didn't check to see if we got off one bus only to get back on the bus we just got off. So we have to make sure that we're not like going in loops. So to do that, we actually need to keep track of which buses we've already been on. So I'll call this used buses. And let's see, initially I'll just make this an empty set. So this set will keep track of which buses we've already ridden so that we don't end up going in loops, riding the same bus again and again and again. All right, then out here, or in here, we'll have to check to see if we've already used this bus. If we have, then we don't want to use this bus again. Actually, I'll check if we're using the bus in here. So let's see. we'll have to create a new used bus list and add this bus to the list. So the new used buses. So we'll have new used buses, and that's just going to be a copy of this used buses. And then we'll add our bus, this current bus, to the new used buses. Now the reason I have to make a copy here is because this used buses is a set, and a set will be passed by a reference, meaning that it will be shared if we pass it through. It's going to share the same set as the parent that was calling this function. Now I don't want that to happen, because if we have multiple recursive calls that all share the same set, that'll interfere. So we actually need to create a copy so that we have a unique instance of this set for every recursive path. All right, and then down here, we'll have to pass this in when we make this function call. Use buses. And let's see, we need to check before we make the call, is this next bus a bus we've already used? So if next bus is in our new used buses, then we'll just continue. All right, we don't want to ride the same bus multiple times. Okay, so that takes care of any cycles. Now let's get back to our two pieces we're missing. One being our start buses, and the other being this connected buses dictionary. All right, so let's create those out here. We have start buses, and that can be a set or a list, so I'll just make it a set. And then connected buses. Now what is this? So the connected buses will have to be a dictionary or an array that, given a bus, will tell us which other buses are connected to the same stops as this bus. So for this, we'll either create an array of sets, or we can have a dictionary of sets. I think I'll make this an array because we already know how many buses we have. So we'll create, let's see, an array of sets for every whatever we have in our routes. All right, so this will basically create an array of size routes. So we'll have one entry for every bus in our routes array, and we'll start with an empty set. So we can index into this connected buses with our bus label or our bus number, and it will give us back a set of all the connected buses. So that does mean in here, when we use this, for every next bus in our connected buses, we have to index this with our bus. All right. Now we still need to build these. So for this one, I'm going to use some set mathematics or set operations. First, I'll create a set for all the routes that are connected to this current bus. And then I'll create a set for all the routes connected to any other bus. And I'll do an intersection to see, is there some intersection between all the routes in this bus and all the routes in the next bus? If there is some intersection, if they share some stops, well, then we can actually connect these two buses. All right, so I think the first thing I want to do is create those sets of stops. So I need to convert this routes, which is a list of lists, to a bus stop list. So it'll be a list of sets, because I want sets of bus stops, not lists of bus stops. So let's see, I'll just call this bus stops. And again, this will just be an array. Actually, I'm going to start it with none for blank in routes. I need the in here. All right. So this bus stops is going to be a list of sets. So then for every bus and stops in enumerate our routes, so this will return the key value pairs or the index value pairs for our routes. So we have the bus, which is the index, and the stops, which are which bus stops we go to. Then we can say bus stops for this bus is just going to be a set of all of the stops. So this set will take in a list of the stops and convert it to a set. Cool. So now I can index into my bus stops with my bus, and it will return a set of all the stops that this bus stops at. That's going to be key to this next part, where we're going to build up all of our connected buses. So the connected buses, again, this is going to be a list where the index is the bus number, and the value will be a set of all the buses that this bus can connect to. All right, so for every bus, Actually, yeah, I'll call it bus. So this is for every bus in range. So this is really the bus number or bus index. We'll go with the length of our routes. So now for every bus, I need to compare its stops with every other bus in my list. So for every next bus in range, and now we don't need to start at 0 for this. We can start at this bus plus 1. So we'll start at the next bus on the list to the length of our routes. Okay, so for every bus in the length of routes, so 0 through the length of routes, maybe I'll do this. Maybe I'll call that a bus count. Let's do that. Bus count equals length of routes. That's going to save us a little bit here. So every bus in our bus count. And then we'll go from every bus plus 1 to our bus count. And now we need to do our check. Do these buses, this bus and the next bus, do they have some shared stops, some stops in common? So if our, let's see, we call this bus stops. If the bus stops for this bus dot intersection with the bus stops for the next bus. So if there is some intersection, then there will be something in here. This will be true. So if the bus stops for this bus intersection with the bus stops for the next bus is not empty, there's some shared stop, that means these buses are connected. So I can add this to the connected list. So the connected buses, this guy here. So connected buses. So this bus is now connected to the next bus. Cool. And this is mutual. So that means that the next bus is also connected to this bus. So I can do the reverse. So the next bus is also connected to this bus. Oh man, so much code. And we're down to less than 10 minutes here. All right, so we've gone through, we built up our bus stops, we built up our connected buses. We still need this starting buses. All right, the start buses. Well, as we're going through all of our buses here, we can just check. Do this really quick. If the source is in the bus stop here, bus stops for this bus, well, that means that this bus stops at our source. So that means this could be a starting bus. So starting buses, we'll just add this bus. Wow, so much code. All right, so I think this is it. We've got all the pieces we need. We have all of our starting buses. We have all of our connected buses. We have a recursive function that goes through and tries every bus till we get to our destination. We're keeping track of the used buses so we don't end up going in loops. And I think we have got it. Oh man, I'm sure I've made some typos or mistakes, but let's just run this and see where they are. Whoa, and it works. Okay, now before I run this, I'm pretty sure this is not going to run in the time that we need. Now, one way I would normally do this is to add an @cache right here to cache the result. Unfortunately, sets are not hashable. That means you can't cache them. But I don't really care about the set in this case. What I really care about is when I have an answer for this bus, doesn't matter what other buses I took, if I have an answer for this bus, then that should be the answer that I cache, and that should be the answer that I return. So let's have some dynamic programming out here. So DP, actually I'm going to call it cache. That's going to be an empty dictionary to start with. All right, so this cache is our dynamic programming. We're going to keep track of when we have an answer for this bus, we're going to put it in the cache. If we have an answer for this bus in the cache, then we don't have to do this whole process again. We can just return that answer. So let's check here. If our bus is in the cache, then we can just return the cache for this bus. But that means we have to find all of our other return statements, which looks like we got one here and one down here. And we have to put our value into the cache. So anytime we return, we have to do a cache for this bus is equal to our result. Okay, now let's try to see if it still works. Still works with 2 minutes left, 3 minutes left. Let's see if we can pass all the tests. And we pass. And we do okay. Not great, but okay. We beat 50% for runtime, 12% for memory. And we're right here in the middle. Now, let's see. It looks like there's quite a spike here. Let's see what people are doing. Oh, interesting. They're mapping the stop to the bus. That's probably smarter than what we're doing. So if you map the stop to the bus, then you can look at those stops and find the connected buses. That is smart. That's smarter than what I did. So yeah, I would study this one because this seems to be a better answer. All right, we're down to 2 minutes left. I think that's all I got today. So this one is a little bit complicated. It's a hard problem, but it's worth doing. If you break it down into smaller pieces and just tackle one piece at a time, this is totally solvable. So try it on your own. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.